Okay, so let's understand this really cool model. It's implemented in sklearn. It's called extremely randomized trees. What it does is it just takes the random forest algorithm one step further. So normally random forest is just column sampling plus row sampling, and yeah, then you have the model building, right? So that's your random forest, and then you aggregate it. You get the final output. Now, extremely randomized trees, what they do is they take randomness one step further. So, like your random forest, they also do column sampling plus row sampling, but they add one more level of randomness over here. I'll explain what it is. So, when you build a random forest, it's basically just building a lot of DTs, decision trees, as your base learners, right? So when you build a decision tree and you come to some level, let's say some level over here, and over here you have a real value, let's say tau less than 2.9 or something. Okay, you have to divide the decision tree based on a real value. So we learned in the decision tree playlist how do we do that. Basically, if we have real values over here, we take every level, every value. We take tau 1, tau 2, tau 3, tau 4, all the way to tau n, and then we divide the tree based on each and every one of the threshold values, and then we see where we have the maximum information gain, and we choose that level of threshold for this particular node, right? But as you would have figured that this is very, very time consuming, because if you have 1000 points in a data set, you'd have to do that for one. You'll have to take 1000 thresholds, find which threshold gives the highest information gain, and then choose that, right? So how do extremely randomized trees add one more level of randomness? Well, they randomly choose these thresholds. Normally, in a decision tree, you would go through all of these threshold points and see where you get the maximum IG, information gain. But extremely randomized trees, they add randomness by randomly choosing some, let's say, 10 values or 10 or 15 values of thresholds, right? They randomly choose some 15 threshold values and they find which one of those 15 threshold values gives a very high value of information gain, and then they choose that threshold as their value at this particular node. Okay, so they do something called random threshold selection. Okay, so you can do that for classification problems, but this is especially useful in regression problems, and that's how they add one more level of randomness to the way they build the model, and they further reduce variance further reduce variance. Okay, so that's it. That's what extremely randomized trees are all about. They're not much different from random forest, but they just add one more level of randomness to reduce variance.